All right, guys, we're back for the second video here, and now we're going to talk about something called uniform motion problems. Uniform motion problems, or rate problems, are problems in which an object moves at a certain speed or rate. The formula D equals RT is used to solve these problems. And the formula D represents the distance, R represents the rate, T represents the time. So usually, I don't know if you've ever heard this before, but distance equals the rate times the time. Think about it. If you want to try to figure out how far you went in a car, and you know you were at 60 miles per hour for 2 hours, well, if you go 60 miles per hour for 2 hours, you multiply the 60 and the 2, you get 120 miles, okay? So that's basically where the distance equals rate times time formula comes in. So it took Travis and Tony 40 minutes to stake 5 miles. The return trip took them 30 minutes. What is their average speed for the trip? So we know that the boys did not travel the same amount of time on each portion of their trip. One way took 40 minutes, one way took 30 minutes. So we'll need to find the weighted average of their speeds. You can't just add the two up and divide by 2 because they didn't take the same amount of time each, okay? So we're asked to find their average speed for both portions of the trip. First, find the rate of going, and then the return portion of the trip. Because the rate is in miles per hour, we convert 40 minutes to about 0.667 hours and 30 minutes to 0.5 hours. Okay, so 40 minutes is 2/3 of an hour. That's where the 0.667 goes. Okay, so going out, we know the rate is distance divided by time. So 5 miles divided by 0.667 is about 7.5 miles per hour. And on the return, same thing. 5 divided by 0.5 is about 10 miles per hour. So because we're looking for the weighted average, we cannot just average their speeds. We need to find the weighted average for the round trip. So that you do the rate of going times the time of going plus the rate of return times the time of return divided by the total time, how long it took to go out, and how long it took to go back. All right, so 0.75 times 0.667 plus 10 times 0.5 divided by 0.667 plus 0.5. And you get 10.0025 divided by 1.167, or about 8.6. So their average speed was about 8.6 miles per hour. So I wanted to also bring up another way that you could possibly do this problem. Okay, so if you notice down here, the rate of going times the time of going, isn't that rate times time? Rate times time equals distance. So the distance of going is just 5. So we'll put that there. Oops, let me make sure my pen is on. Plus the rate of return times the time of return. Well, the rate of return times the time of return is also 5 miles, divided by the time of going plus the time of return. The time of going was 40 minutes, plus the time of return was 30 minutes. So you would have 10 over 60. Now, when we divide that out, it looks like you're not going to get the right answer, because if you do 10 divided by 60, you get 0.1 or 1.1666666, and so forth and so on. But notice that 5 is in miles and 60 is in minutes. And our final answer is in miles per hour. So the problem asks, what's their average speed for the trip? It didn't say, make sure your answer is in miles per hour. But we just did that because we usually talk about miles per hour, not miles per minute. So what we can do is just convert this to miles per hour. The units for distance are already miles. The units for time are minutes. So to change it from minutes to hours, we need to convert it with the conversion from minutes to hours. Now, you know there's 60 minutes an hour. I'm sorry, this should have been a 7. And so here, that would be 10 divided by 70, which is 0.142857, and so forth and so on. Anyway, back to converting the miles per minute to miles per hour. You know that there's 60 minutes in an hour, so where's the 60 go? Well, since we need to cancel out the minutes in the conversion factor need to go in the numerator so that these cross cancel. So it's going to be 60 over 1. So if you multiply straight across, you would get 600 over 70. And if I do that here, 600 divided by 70, you get 8.57, which rounds to 8.6 miles per hour. So you get the same answer there. I'm not sure why in the book they made you do it like this, because the rate times the time gives you the distance, and they already gave you the distance here. I think they're just showing you how to do it in case you might not know the distance. Sometimes they do just give you the rate and the time, and you have to figure out the distance. Okie doke. All right, so our solution of 8.6 miles per hour is between the going portion rate of 7.5 miles per hour and the return rate of 10 miles per hour, so we know that our answer is reasonable because it's going to be a weighted average of the two. But again, you can't just add the 7.5 and 10 divided by 2 because they didn't take the same amount of time each. Okay, here's one for you to try. Go ahead and pause the video and hit play when you're ready to begin. All right, we're back. Austin jogged 2.5 miles in 16 minutes, then walked 1 mile in 10 minutes. What is his average speed? So his average speed is going to be the distance divided by the time. So his first distance is 2.5 miles, plus his second distance is 1 mile. Right? Okay. So then his total time is 16 minutes that way plus 10 minutes the other way. So that's 3.5 divided by 26. And when you divide those out, you get about 0.13. Now the units for the numerator were miles. The units for the denominator were minutes. So this is 0.13 miles per minute. Now, if you wanted to convert this to miles per hour, you'd have to multiply by the conversion factor of minutes over hours, which you would do 60 minutes over 1 hour. But here's what I want to show you also. What we did here, the 0.13 is rounded. Okay, so if I did 3.5 divided by 26, you get 0.34615, blah, 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 blah. Okay, so if you're going to convert it to hours, make sure you use this number and then multiply it by the 60 and get 8.07, then round it. Okay, so about 8.1 miles per hour would be your answer for that one. Okay? Now remember, you never want to round till your final answer, because if you round, then do another step, round, do another step, round. After you do that 2 or 3 or 4 times, you've rounded so much and multiplied, added, subtracted, divided, all those rounded answers, that your final answer may be nowhere near the actual real answer, even if you did all the steps correctly. Okay, so the formula D equals RT can also be used to solve real-world problems involving 2 vehicles in motion. So 2 trains are 550 miles apart heading toward each other on parallel tracks. Train A is traveling east at 35 miles per hour, while train B is traveling west at 45 miles per hour. When will the trains pass each other? So it helps to draw a diagram. You have this one coming at 35 miles per hour, this one coming at 45 miles per hour. And right at the moment we took the picture, they were 550 miles per hour. We want to know, when are they going to pass each other? All right, so let T equal the number of hours until the trains pass each other, and let's make a table. Train A, its rate is 35 miles per hour. Its time is T, we don't know it. The distance is 35T. Train B, its rate is 45 miles per hour. Now we use the same time because it's going to be the same amount of time from this picture until the trains meet. Okay, because they're both starting at 550 miles apart, so it's going to take the same amount of time until they meet. Now they're going at different rates, so they might have traveled different distances to get there. Okay, but you know, if the answer is 2 hours, each train had to go 2 hours and then they meet. Okay, so let's write and solve an equation. The distance traveled by train A plus the distance traveled by train B should equal 550 miles because we know how many miles there are. So 35t plus 45t equals 550. Add those together, you get 80t equals 550. So divide both sides by 80 and you get t equals 6.875. Okay? All right, so the trains will pass each other in about 6.875 hours. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready to check your answer. All right, we're back. Two cyclists begin traveling in opposite directions on a circular bike path or bike trail that is 5 miles long. One cyclist travels 12 miles per hour, the other travels 18 miles per hour. How long will it be before they meet? So here's the bike path. They start, this guy goes this way at 12 miles per hour. This guy goes this way at, how fast? 18. And the whole thing is 5 miles around. That's just supposed to be a circular arrow. Okay. How long will it be before they meet? So we don't know their names, so we'll call them the one guy and the other. Okay, so we know the rate of both of them. The rate of the one guy is 18, and the rate of the other guy, or excuse me, his was 12. And the other guy is 18. The time, that's the variable in question, so we'll call that t for both of them. And it's going to be the same amount of time because they're going in opposite directions until they meet. And the distance, which is rate times time, we actually know the answer to that is 5. Okay. Now, what we do is we know that their rate times time, their distances added together should equal 5. Actually, I wrote the wrong number there. The distance equals rate times time, so that's 12t, and this is 18t. Okay, we know that the track is 5 miles around, but we don't know the distance that each one of the guys has to bike. Okay, but we do know the rate, and so the distance is equal to rate times time. So 12t for this guy and 18t for this guy. So all we do is add those together, and we know that since they're traveling in opposite directions, they start here. This guy travels this way, this guy travels this way. They're going to meet somewhere else. So we know when they meet that their total distances added together has to be 5 miles because they start at one point, go in opposite directions around a circle and meet somewhere else. So however much this guy traveled added to however much this guy traveled has to come out to be 5 miles. All right, so that's going to be 30t equals 5. So divide both sides by 30. And you get t equals 1. Ooh, what happened there? T equals 1/6. I don't know what I did. Oh, I switched it to highlighter. That would be why. My hand touched it. All right, so 1/6 of an hour. Okay, it's not 1/6 miles per hour because again, the answer is time. How long did it take? 1/6 of an hour. Well, 1/6 of an hour, you can think, well, 1/6 of an hour, how many minutes would that be? Well, there's 60 minutes in an hour. 1/6 of that would be 10 minutes. All right, so either way is fine because the problem didn't specify. Make sure your answer is in minutes or make sure your answer is in seconds. So 1/6 of an hour or 10 minutes. But if it does specify which way to report your answer, make sure you put your answer in terms of either minutes or hours, whatever it asks for. All right. All right, guys, that's it for this section. Thank you for your time. I hope that was helpful to you. If you have any questions, reach out to me. And as always, make it a great day and reach out to me if you have any questions. Take care.